When making modifications to an existing farm service, specifically when adding a terminal box on the load side of the service disconnect, it's crucial to understand the requirements outlined in the National Electrical Code, or NEC. The existing scenario involves a 200 amp farm service with a pole-mounted meter and a service disconnect transfer switch for a generator. The owner's desire to extend power to another shed necessitates careful consideration of code compliance. The existing code violation of having 3 wires under the load side lugs of the service disconnect further emphasizes the need for a thorough assessment. The question at hand is whether installing a terminal box on the load side of the service disconnect necessitates the service disconnect being a fusible type. The answer is yes. If a terminal box is installed on the load side of the service disconnect must be a fusible type. This requirement stems from NEC 230.70 A1, which mandates overcurrent protection for conductors sized for American wire gauge, or AUG, and larger at their termination point when they are connected to bus bars or other conductors. A fusible service disconnect achieves this overcurrent protection through the use of a fuse or fuses. These fuses are designed to blow or open the circuit if the current flowing through them exceeds a predetermined level. This action safeguards the conductors and equipment connected to the service disconnect from potential damage resulting from a fault or overload condition. To elaborate further, let's delve into the specifics of NEC 230.70 A1. This section of the code addresses the location of overcurrent protection devices in service conductors. It stipulates that the overcurrent device must be an integral part of the service disconnecting means or located immediately adjacent thereto. This proximity is essential to ensure that the conductors are protected from overcurrents as close as possible to their source of supply. Now consider the scenario where a terminal box is added on the load side of the existing service disconnect. This terminal box essentially creates a new termination point for the service conductors. Since these conductors are 4 AWG or larger, NEC 230.70 A1 dictates that overcurrent protection must be provided at this new termination point. A fusible service disconnect fulfills this requirement by incorporating fuses that are sized appropriately to protect the conductors based on their ampacity. The ampacity of a conductor refers to its current carrying capacity, which is the maximum amount of current it can safely conduct without overheating. The NEC provides tables that specify the ampacity of different sizes and types of conductors, taking into account factors such as insulation type, ambient temperature, and the number of conductors bundled together. When selecting fuses for a fusible service disconnect, it is imperative to choose fuses with an ampacity rating that is equal to or less than the ampacity of the conductors they are protecting. This ensures that the fuses will blow before the conductors are subjected to an overcurrent that could cause them to overheat and potentially lead to a fire. In contrast to a fusible service disconnect, a non-fusible service disconnect typically consists of a simple switch or circuit breaker that is used to isolate the service from the load. While a non-fusible disconnect can provide a means of disconnecting the power, it does not offer overcurrent protection. Therefore, in the scenario where a terminal box is added, a non-feasible disconnect would not satisfy the requirements of NEC 230.70 A1. It is important to note that the NEC is a comprehensive set of standards that is updated regularly to reflect advancements in technology and to address emerging safety concerns. It is essential for electrical contractors and installers to stay abreast of the latest code revisions and to adhere to all applicable requirements. Failure to comply with the NEC can result in fines, project delays, and, more importantly, increased risk of electrical hazards. In the specific context of the farm service upgrade, the existing code violation of having 3 wires under the load side lugs of the service disconnect must also be addressed. This practice is generally prohibited by the NEC because it can lead to loose connections, overheating, and potential fire hazards. The NEC typically requires that only one conductor be terminated under each lug, unless the lug is specifically designed and listed for multiple conductors. To rectify this violation, the existing service disconnect should be replaced with one that is properly rated and listed for the number of conductors being terminated. Alternatively, a separate terminal block or junction box can be installed to provide individual termination points for each conductor. Furthermore, it is crucial to ensure that all connections are made properly and tightened to the manufacturer's specifications. Loose connections can create resistance, which generates heat and can lead to premature equipment failure or even a fire. In addition to the requirements of NEC 230.70. 8.1. Other sections of the NEC may also be relevant to the farm service upgrade. For example, NEC 250 addresses grounding and bonding requirements, which are essential for ensuring electrical safety. NEC 300 covers wiring methods and materials, and NEC 408 addresses switchboards and panel boards. It is recommended that a qualified electrical contractor be consulted to ensure that all aspects of the installation comply with the NEC and other applicable standards. The electrical contractor can also assist with selecting the appropriate equipment and materials, as well as performing the installation in a safe and professional manner. In summary, when adding a terminal box to an existing farm service with conductors sized 4 AWG or larger, the service disconnect must be a fusible type to comply with NEC 230.70. A1. This requirement is intended to provide overcurrent protection at the termination point of the conductors, safeguarding them and connected equipment from damage due to faults or overloads. Furthermore, any existing code violations, such as multiple conductors under a single lug, must be rectified to ensure a safe and reliable electrical installation. Adherence to the NEC and consultation with a qualified electrical contractor are essential for a successful and code-compliant farm service upgrade. The selection of the appropriate fuse size is critical. Fuses are rated in amps, indicating the amount of current they can carry before interrupting the circuit. Selecting the correct fuse size involves considering the ampacity of the conductors being protected and the load they will serve. Oversized fuses will not provide adequate protection, while undersized fuses will cause nuisance tripping. The NEC provides guidelines and tables to assist in determining the appropriate fuse size for various applications. Installation practices also play a significant role in the safety and reliability of the electrical system. Proper wiring techniques, secure connections, and the correct use of tools are essential. All work should be performed by qualified personnel who are familiar with the NEC and other applicable standards. Regular inspections and maintenance can help to identify potential problems before they become serious hazards. This includes checking for loose connections, damaged wiring, and signs of overheating. Addressing these issues promptly can prevent equipment failures and ensure the continued safe operation of the electrical system. The service disconnect plays a vital role in the overall electrical system. It serves as the main point of isolation for the electrical service, allowing the entire system to be de-energized for maintenance or in the event of an emergency. The service disconnect must be readily accessible and clearly marked to facilitate its operation. In addition to the service disconnect, other disconnecting means may be required at various points throughout the electrical system. These disconnecting means allow individual circuits or equipment to be isolated for maintenance or repair. The location and type of disconnecting means will depend on the specific application and the requirements of the NEC. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, allowing the overcurrent protective devices to trip and clear the fault. Bonding connects all metallic parts of the electrical system together, creating a low impedance path for fault current. The NEC provides detailed requirements for grounding and bonding, which must be followed carefully to ensure electrical safety. Surge protection is another important consideration for electrical systems, particularly in areas prone to lightning strikes or power surges. Surge protective devices, or SPDs, can protect sensitive electronic equipment from damage caused by these transient overvoltages. SPD should be installed at the service entrance and at other critical locations throughout the electrical system. In the context of a farm service, special considerations may apply due to the presence of livestock, agricultural equipment, and outdoor environments. The NEC includes specific requirements for agricultural buildings and installations which address issues such as corrosion, moisture, and the potential for physical damage. It is important to consult these requirements when designing and installing electrical systems on farms. The requirement for a fusible disconnect when adding a terminal box stems from the fundamental principle of overcurrent protection. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect conductors and equipment from damage caused by excessive current flow. When a fault or overload occurs, the overcurrent device will interrupt the circuit, preventing the current from reaching dangerous levels. The selection of the appropriate overcurrent device is critical for ensuring adequate protection. The overcurrent device must be sized to protect the conductors based on their ampacity, while also allowing for the normal operating current of the equipment being served. The NEC provides guidelines and tables to assist in determining the appropriate overcurrent device size for various applications. In addition to the fuse size, the interrupting rating of the fuse is also important. The interrupting rating is the maximum amount of fault current that the fuse can safely interrupt without failing. The interrupting rating must be sufficient to handle the available fault current at the point of installation. The NEC requires that the interrupting rating of overcurrent devices be clearly marked on the device. The available fault current can be calculated or measured using appropriate methods. The electrical inspector is typically responsible for verifying that the interrupting rating of overcurrent devices is adequate for the application. When selecting a fusible disconnect, it is important to choose a product that is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all. Listing and labeling indicate that the product has been tested and meets applicable safety standards. The listing mark will typically be found in the product itself or on its packaging. The electrical inspector will typically look for the listing mark to verify that the product is approved for use. In addition to the NEC, other codes and standards may also apply to the farm service upgrade. These may include local building codes, fire codes, and utility company regulations. It is important to consult with the local authorities to determine which codes and standards are applicable. The electrical inspector is typically responsible for enforcing the NEC and other applicable codes and standards. The electrical inspector will review the plans for the installation and perform inspections to verify that the work is being done in accordance with the codes and standards. The electrical inspector has the authority to require corrections to be made if the work does not comply with the codes and standards. The electrical inspection is an important part of the overall process of ensuring electrical safety. It helps to identify potential problems and ensure that the electrical system is installed correctly and safely. The cost of the fusible disconnect will vary depending on the size, type, and features of the device. It is important to consider the total cost of the installation, including the cost of the fusible disconnect, the wiring, and the labor. Obtaining multiple quotes from different electrical contractors can help to ensure that you are getting a fair price. The installation of the fusible disconnect should be performed by a qualified electrical contractor. The electrical contractor will be responsible for ensuring that the installation complies with the NEC and other applicable codes and standards. The electrical contractor will also be responsible for obtaining any necessary permits and inspections. The use of a qualified electrical contractor is essential for ensuring a safe and reliable electrical installation. The farm service upgrade is an important project that can improve the safety and efficiency of the electrical system. By following the NEC and other applicable codes and standards, and by using qualified personnel, you can ensure that the project is completed successfully.